Hello everyone, I'm the Liang Chen and welcome to this talk. Today I'm going to present our work in WCV 2021, the Temporal-Aware Self-Supervised Learning for 3D hand pose and mesh in video. So as we all know, to train a good 3D hand pose and mesh estimator, we need a large-scale dataset with accurate 3D annotations. However, labeling 3D hand key point ground truths is very labor-intensive, and labeling 3D hand mesh is even an impossible task for human being. But however, recently with the rise of the self-supervised learning, we have the alternative way to train 3D hand pose estimation even without 3D ground truths. There is a prior work done on CVPR 2019, and they apply the self-supervised learning method by using multi-view constraint. In this work, they had a multi-view depth image dataset. During the training, they first estimate a hand mesh from one single depth map, and then they rendering the new depth map based on the estimate mesh from several fixed angle, and then they compare the new rendered depth map with the ground truth depth map, and based on that training signal, they can train the estimator even without the 3D ground truth. So besides the multi-view constraint, what else can we do to apply the self-supervised learning? So we are doing the temporal constraint. So in our method, we propose a new temporal constraint to train the hand pose estimation. And our pose and the mesh estimator would predict the pose and mesh based on temporal information. We will run our model twice. First, we run it by forward order, following by the back order, because the estimation on the same frame should be the same. So we could, in this way, we added a temporal constraint to make sure our pose and mesh estimator had the same result on mesh and pose when it applied on the same frame in both forward and backward inference procedures. So here going to talking about the detail of our post-mesh estimation. So first we are using the optical floor to extract our temporal information, and the heat map estimator will take the optical floor and the heat map from previous frame to produce the features and the heat map for the current frame. And we also apply the GC hand mesh estimator to take the image feature to produce a hand mesh. And then a hand pose estimator will take the mesh from the mesh estimator and produce the hand key point estimation for the current frame. Here, because we don't have the 3D ground truth, to add the 3D information, we're using a silhouette loss to train the hand mesh estimator. And here is ablation study of our TASSN. As you can see, without the temporal loss and the temporal mesh loss, the result is pretty bad. Just compared to the TASSN is 0.77, and if we don't add the temporal constraint, the result well down to the 0.54. And here is compare with our model with several state-of-the-art methods. So our model is trained without any 3D ground truth, but still it is very close to those state-of-the-art methods, which they has a 3D ground truth. And it shows that the effectiveness of our method. Thank you, everyone, and any questions?